I'm gonna go with 50%, and I think
that's a lot.
I think that's a lot. Yes.
Something that changed your mind.
Is basically the fact that everybody is, you know, just like you and me, or like there's nobody that's kind of unreachable. Let's say, not being afraid of, contacting people. Just ask. People will say no most of the time, but sometimes they will say yes. An anecdote. And then there was a guy that asked, and how about reading the plates? You don't want to downsell the capabilities of satellite images, but at the same time, it's like, come on, man. Yeah, it's not the movies, exactly. What we are trying to do with neural network pruning is to detect which are the neurons that are contributing less to the network, right? So one of the things that we know about our brain, and it also happens the same with artificial neural networks, is that there's a lot of redundancy, meaning that there's a lot of neurons that you can just remove them with no effect or very, very little effect to the way that the network works. The paradigm for pruning was, first you take a network, you train it, and then once the network does what you want to do, then you see which are the less useful parts of the network, right? But what we are trying to do is to do this before training, right? So it's going one step further and say, okay, before I train the network, so before I know which parts of the network are going to be important, can I really say something about about the network? And it turns out that you can actually say a lot. Now, if you do pruning at initialization, the good point about it is that you can have these benefits not only at inference time, but also when training the network. And usually when you train is like when you consume the most of the resources, right? Training a model is much more expensive than just doing inference. Intuitively, what we want is to find all of the connections that when they are perturbed, the loss changes a lot. So the only thing that you care about is the fact that that connection is really linked with the output. So if I tune this knob, I know that something happens here. I don't care if it happens in the direction that I want it to happen. I just know that, this knob is important. Pruning at initialization can be thought of as neural architecture search, but in a very constrained way. So in pruning or skeletonization, what you would have is you start with an overparameterized network, and then you're not changing the architecture, but you're just changing the inner topology of the network, right? So from the whole network, you will end up with a subnetwork, which will ideally work as well as the original one.
And do you think your method is better than existing ones?
All of the weights, are kind of they have some kind of interactions, right? So basically, when you perturb one or you set one to 0, then it will also affect the others. So what we found out is that when you try to go to high sparsities, so you try to remove a lot of weights at the same time, then these approximations are not very good. So instead, we suggested a variant of that approach, where we remove the weights iteratively. And what we do is we recompute the importance of each of the connections at each step. So this way, the transition from the dense network to the prune network is much smoother. When we push for higher sparsity, so we remove a lot of connections, then we are better.
Like, what percentage of connections do you remove?
In general, we were able to remove up to 99.9% of the connections. I mean, I didn't even think that I would manage to end up my my mathematics degree. So, for example, that part is already quite an achievement. Yeah, like in every step, there's always a struggle, and you're always kind of unsure whether you're gonna make it or not. And then, usually in the end, it ends up being fine. A small bar or whatever is not gonna do or have the same needs as Google or Facebook. But I think people are realizing more and more that having some metrics and some measurements over some key parts of their business is really helping them to know what's going on, and to know if I change this, how does it affect the revenue. There's a lot of hype from general public about what artificial intelligence can do. This image that we have of Terminator or whatever. So we can create algorithms that are able to play chess or Go, way better than most humans. But then if you just Google, DARPA failures, then you will see a lot of robots trying to open a door and then falling on their side, or just driving a car and crashing everywhere. And so there's some things that apparently come supernatural to humans, and that's really hard to be able to program or to learn.
But do you think we will get there?
When you go from the simulator to real life, that usually breaks. So there's a domain adaptation problem, but more and more there's new advancements in that regard. So on its own, quantity does not affect quality. Yeah, what I do ends up happening is that there's this pressure for publishing now, because the problem is that everything's moving so fast, and especially in deep learning and machine learning, like this field where you are publishing in conferences, you go from one deadline to the next deadline, right? And in between you have 3-4 months at most to improve the paper if it got rejected, or to think about a new project, and these kind of things. And what ends up happening is that you just do these short-term projects, and you just try to get rid of ideas as soon as possible, right? It kind of foments this this type of research, like fast food research. Still, there is very good papers, and there's still people that comes up with great ideas, and you just have to see how the field has progressed. There's just so many papers that it's just overwhelming. You have one idea, and then you find 3 papers that have already implemented, right? It's definitely getting tougher to do research. There's a need for changing a little bit the way that we evaluate research. 30% luck, and then 70% the fact that I did have good grades of my first semester in the master's. I started with Andrew NG. He's got a course in Coursera, and now he actually made a different website, which is deeplearning.ai. I think those videos are very, very interesting for someone who wants to learn more about machine learning.